Hi, welcome everybody. I'm Rosalie. I work at Panoptic. I'm here with Steve from Panoptic and Mario from Cantina. Welcome, guys.
Hey, Rosalie, how are you?
Good,
Hey,
good.
hey.
Awesome. Well, thank you so much for joining me today. We are going to be talking about our rescue operation and discuss the vulnerability a little bit. Before we get started, I would love for you guys to introduce yourselves and just share a little bit about it, what you guys do, and yeah, we can get started then.
Yeah, absolutely. I'm Steve. I'm the head of engineering at Panoptic. I work on protocol itself, the core smart contracts, as well as the web app that serves Panoptic to our users. I work alongside a great team. Guillaume contributes code, who's been on this live stream much more than I have. Luis as well, um, and Brandon, our PM, has even started coding. I'm part of a larger technical team, but yeah, I work on delivering the product and handling security incidents like the one we're going to talk about today.
Awesome. I'm Mario. Hello, everyone. I'm lead security researcher on Cantina. I'm also head of incident, and I aid the incident rescues, war rooms, and so on inside Cantina with our team. And I think that's all for me.
Awesome. All right. Well, I think we can just probably dive right in. I have some questions for you guys, and we can go over the details of kind of just start by like explaining what happened on August 25th and what you discovered, and just, yeah.
Yeah, absolutely. On August 25th, we received a report from Cantina about midday. This was part of our bug bounty program. We had a $250,000 bounty out for anyone to submit problems with the core smart contracts. And this was after a number of audits that we had done pre-launch. So the idea was if anything wasn't captured in the audits, that would mean live funds are at risk, right? The protocol had 5 million of TVL, and people were searching for problems that could put that money at risk, and we wanted to hear about it first so we could handle it before a black hat got to those funds. So we had this live bounty up, and we received a submission. We actually had received a number of those over the 9 months we were live. This was our 21st submission, and so every time we receive one of them, I would usually take between like a couple hours and even like a full day sort of analyzing the submission, right? Trying to understand, what does the researcher claim is the impact and how it works? Are they correct? Or are they at least like sniffing in the right direction? Like maybe they're slightly wrong, but there's something related that could be a problem. So this is a big part of our work here at Panoptic. All those submissions are valuable and we learn from them every time. But at the same time, when you receive 21, right, eventually you're not really totally sure how real the next one is going to be. So I went in, started to analyze it, was kind of trying to prove why this wasn't a problem. And I would say about like 2 hours into my analysis, it was really feeling like there could be a problem here. So I raised it to the team. And we'll get into the specifics of the vulnerability, I guess. But the quick version is that the researcher claimed that they could fake what positions they owned. So Panoptic is an options protocol built on top of Uniswap, where the underlying positions are LP positions. And when you own a position on Panoptic, you sometimes borrow tokens from other users, right? So you have a collateral requirement to pay back those lenders, and you could open a couple of positions that have high collateral requirements. And if you were to lie about what positions you own and say that you actually own low requirement positions, this is a big problem, right? It allows you to take funds out that are actually owed to people who are lending their tokens to you. That's what the researcher claimed. And the key step here, right, is, okay, well, how do you fake it, right? What are you fooling in order to tell the contracts that you actually own these positions when really you own these other positions? And so I was working through that. I thought it was a real problem. I brought it up to the team. We thought it might not be a problem because of one key step that we use to validate those claims, right? When you say what positions you have. And so then we kind of went back and forth with the researcher a little bit, but then he really underlined, he's like, no, I know I can get around this because of X, Y, Z. So after some interaction with the researcher, we felt confident that this was a real problem. And then the next step was, okay, did this researcher kind of get lucky? Did they find like one pair of positions that they could fool, Or is there a way to generically reproduce this kind of attack? And so I then spent a couple hours as well trying to reproduce the attack, produce other sets of fakeries, basically. And once I was able to do that, we definitely knew funds were at risk. So we raised the alarm. We reached out to Cantina's incident response team. We reached out to SEAL 911, and we got as much support as we could in order to understand what the next steps were. And the first recommendation was definitely like contact all the users you have contact for, right? Because that's the easiest way to keep funds safe is if you can get people to remove their funds voluntarily without leaking the presence of an attack, that's a really easy step. Execution wise, now the risk there, right? You're trading off against what's the likelihood that the information about the attack leaks, because as soon as people know there's a problem with your contracts, that's like a beacon to black hats to come and start playing around and try to find a problem. So we wanted to avoid kind of putting a target on our users' backs while also trying to get as much funds out as possible. So we were executing that trade-off, trying to find the right users who we felt would keep things under wrap while also getting their money out. We executed that for a little while, and then August 26th, 27th, 28th is when we actually built the white hat, executed it, and got funds out, which I'm sure we'll talk about more. But that's kind of a quick version of what happened on the 25th.
Yeah. Thank you for sharing that. Yeah, it was definitely a crazy experience to be a part of and trying to find everybody's wallets and see who's who. Definitely crypto makes that a little bit more difficult sometimes, right? Because we don't have an email or account, nobody we can really call. And so that was definitely pretty hot and heavy. That I remember those days. Mario, what was your experience like from being a researcher and being used to these kind of things, expectation wise, and how you managed like supporting people? And did you expect this to happen? Like, kind of walk us through your thoughts there.
Yeah, so we've been doing this for some time, unfortunately, and from our point of view, whenever I mean, when we got the alert, we got in and we tried to contain. Basically, that's basic of our our playbook is first we try to triage and see what is the actual issue, and then we try to contain because that's our number one priority. Our number one priority is to make sure that the users' funds are safe. So we worked with the team, which was super. With your team, which was super. I mean, we really like that you were engaged into the war room, and you did not lose yourself, because we see this unfortunately from time to time when things like this happen, emotions cover your thinking, and you don't think straight. But your panoptic team was actually super responsive, and they were on top of things, and they actually tried they did everything possible to make sure that first we contain and we don't need the information. And I really appreciate that, and that's a kudos to you guys, because you had prepared and you kept your calm. And it's okay, even though we have an issue, let's see how we can solve it safely and not rush into things and do a mistake that can cause actually the loss. It happened in the past, but you guys did pretty good. So yeah, rushing into the war room, it was always okay. Let's see how we can get as much money as possible out of the market, making sure how we can contact. We did on-chain tracing. We did reach out to multiple partners to trying to see if we can manage to alert the users. And it was a hectic but controlled rescue operation. And that was after a while, of course, and after we managed to get as much fund as possible out, we had to basically perform a white hatting operation for the rest of the funds. And I will let Steve here maybe continue a bit how that went from his point of view, and then I can also complete the rest of the things.
Yeah. Oh, go ahead, Rosalie.
No, I was just gonna say, I was wondering, yeah, we definitely did everything we could, and getting out the funds was our main priority. And then no funds were lost, so I think that's definitely a good sign, obviously, right? And so just wondering if maybe this could have been detected earlier, and just kind of figuring out why it wasn't, and just understanding that vulnerability a little bit more before we go to the white hat hack.
Yeah. So the vulnerability involves, and this would maybe be a good time to pull up the code that we tweeted out, but so in Panoptic, you own different positions, which are options trades. Under the hood, these are composed of Uniswap LP positions. We could store all the information about those positions in the contracts. So we could say, okay, you own a sold put, which under the hood is a Uniswap LP position from tick 1 to tick 7, let's say, in the ETH-USDC pool. And you might own 10 different positions. And then if you wanted to remove one of these positions, you want to close it, we would have to iterate through the list, find the correct one, pull it out, and then update all that storage. So this would get really gas inefficient really quickly. Users would have to pay like tens to hundreds of dollars to make a trade, which is not something we wanted. So when we built the contracts, we instead aimed to store a fingerprint of your positions. So instead, we were trying to come up with some algorithm where if we did something with a list of positions that you supply, we could then arrive at a claim fingerprint and compare it to the stored fingerprint. And that way we know that if you're telling us you own this set of positions, it's actually true. And you can't try to fake it and say, oh, I actually own these really cheap positions, so you should let me withdraw all these tokens, that are used to fuel my real positions. So that was the aim. And we did it incorrectly. We would take what's called a hash of your position. And so a hash is a one-way mathematical function. You take the details of your position, which could be the lower tick, the upper tick, and so on. You represent them as numbers. You put them into this mathematical function, and you get a number out. And so this is really standard in crypto. People use hashes all the time to identify, the unique traits that would make a unique position. And then, so you own many positions in Panoptic, right? So we would take the hash of each position and we would combine them together using an operation called XOR. And so what that does is numbers can be represented as a binary string, right? That's just the same as representing a decimal like you normally see, but with digits of only 0 and 1. And so we would take that and then we would lay the bit strings out, right? The binary string next to each other of the two hashes. And when you XOR, you combine those two, you take the matching numbers, right? So the 0th number in the binary string for your two hashes, it could be 1 and 0, in which case XOR would tell you 1, and so on. So it's just an operation that combines these binary strings. And we thought this was clever, mainly because what's nice about XOR is that you can combine hashes in any order you want, and it still gets to the same output, right? So if you happen to pass us the first position and the 7th position and then the 6th one, that's the same as if you pass it in the correct order. And this matters a lot for the gas efficiency that I was talking about, where when we want to go and find which position you're closing, we have to go through the list. If we had to have a correctly ordered list every time, we'd have to do a lot of math to actually order the list properly every time we want to do this operation. So that was the motivation. Now, what we didn't know is that XORing together hashes is a known incorrect thing to do. There are known ways that people could fake fingerprints when you're combining hashes together using XOR. And so that's what this code snippet, or I guess this is the research paper from Bellare and Michiangio. And the researcher from Cantina submitted this as well, which was a huge help. They cited both this and also a researcher named Wagner on K-trees, which is kind of a different way to find the same issue. But essentially, combining together hashes using XOR leads you to then, you leave the door open for people to submit a different set of hashes that just happen to XOR to the same final output, to the same fingerprint. So that's what the attacker did, is they implemented the research found in this paper. They implemented a script that would allow them to mine for a list of positions they could tell Panoptic they own. And Panoptic would accept these positions as real positions, would hash them, and then XOR them together and arrive at the same fingerprint as their real fingerprint. So, like I said, when we got this submission, we initially wanted to check that this was real for the case that the researcher supplied. They actually showed us, they said, hey, you have a real pool that has 3 million in it, and here's how I would fake my positions to it and extract the money out. So the first question we have to ask is, okay, we believe them. We tested it, we ran the tests, and we said, okay, they are right. They could steal from this pool with this list. But did they just get like really lucky? Did they just happen to find a great fake, and maybe it would take like years in order to actually find another? And so we then, on our side, implemented that script ourselves, reading the research, and we actually improved upon their attack. We made it a little more economically efficient. And we found that actually even regular laptops could run this same process to mine for these fingerprint collisions. So that's when we really knew there was a problem, and that it would not only apply to the pool the researcher was talking about, but every single pool as well. So this is kind of an important part of understanding the scale of the issue. But yeah, that was in short words what the attack was.
Very interesting. Yeah, we got really lucky with the researcher. It's great that we have these bug bounties and audit firms and people who are really trying to break these protocols for a good purpose, right? Not to steal funds, but to actually help. Talking about the white hat hack now, walk me through that? Did we kind of just use the same attack on our own protocol to remove the funds, or what should I be imagining here?
Yeah, we definitely followed the researcher's lead. So we produced a similar attack where we would open positions on Panoptic that have deeply in the money options. And so what does it mean to be in the money? It means that you might have the options themselves are described as having a high value of like extractable value currently, intrinsic value. And so you might have a sold put, right, where you make more money when the price goes up. It's a bullish position, right? And so if we made it so the strike of that sold put was far enough in one direction, you would have a lot of intrinsic value if you close the position. Now, normally, this is fine because people are just supplying their own deposits. And if you, for some reason, chose to open a really in-the-money position, you would basically just get the same value of your deposits out, because that position should also have a high collateral requirement. Now, if you're allowed to fake what positions you own, you can combine a couple different steps to extract money out. So the first thing you have to do is you have to go borrow a lot of money, right? And so you might use Aave or something else and do what's called a flash loan. Flash loans allow you to take a lot of money so long as you return it by the end of the same transaction. So you borrow a lot of money and you use that money to open a deeply in the money position on Panoptic, which has a high collateral requirement, but also high intrinsic value if you were to close it. And then you make a second call to Panoptic within the same transaction and you say, okay, now I have this fake list of positions that have a really low collateral requirement. So I would now like to withdraw all money associated with my account, even though theoretically that money should be tied up backing that in the money position that you opened in the first transaction. So that's step two. That allows you to get the money out. And then step three, you just simply return the money back to the flash loan providers. That could be Aave or Morpho or what have you. This has to happen in one transaction. And so what we did is we implemented a smart contract that would do this when called. And then we implemented a second smart contract that would allow us to run that attack in the contract deployment, which is really an important step because we want this whole attack to happen atomically in one transaction so that MEV researchers couldn't try to replicate the attack with their own funds or something like that. And so that's what we did is we wrote one of these attacker contracts that deploys, takes a flash loan, opens an in-the-money position, and then withdraws collateral that should be backing those positions and pays back the flash loan and keeps the profits all in one step. It does it at the deploy time. We wrote one of these for every single one of our pools that had like substantial TVL on each chain. And then we prepared to run these as forged scripts. And so this was where the Cantina team was extremely helpful in terms of helping us kind of think through all the adjacent parts of executing the attack that you might not think through at first, right? Because we were really focused on how do we actually execute the smart contract of the attack, right? How do we make sure we open the position correctly and extract the money out properly? But there's all these other things you have to think about, such as making sure that you don't broadcast through an insecure source that actually leaks the attack, right? So they pointed us to the Flashbots RPC, and then they also got us in touch with the Flashbots team when we actually were hitting rate limits on the RPC. That was a really important part of making this go well. So we executed on mainnet first. That's where the majority of the TVL was. We then queued up similar executions on the L2s and tried to communicate. We initially thought we might even go directly to the sequencer, but we decided that we could trust Alchemy, so we went through Alchemy on those chains. But yeah, we executed and retrieved, I think, over 80% of funds in the first batch of executions. Theoretically, the attack was maybe out there by now and somebody could reverse engineer it. but we came back later that evening to get the other substantial markets as well, which got us up to like over 99%. And yeah, now the claim process is live. So we're going to make people 100% whole. And so that last like 0.1% that might still be out there, we'll just be dealing out of our treasury. And yeah, that's the plan.
Awesome. Yeah, if you haven't yet, we have our claim link live. We'll post it again later as well, where you can get your funds back. Just follow a couple of steps. It's really easy. Mario, having been used to these kind of incidents, how do you feel about the white hat hack? Do you see these operations usually panning out this way? Or are there different ways other protocols kind of approach these things? And yeah, just walk us through that.
Yeah, so whenever thinking about the white hat, it's actually we have some checks that we because we've done so many, we have some checks that we basically have in our run book, right? Basically the book that let's say we are following all of these steps. First is that we have to make sure that the team does not, as also Steve said, it does not leak the information before, something like before actually being executed and then being thrown around and the funds being basically replayed and submitted on another address. The second thing, it's also important that after the white hat, you make sure the funds are retrievable. So it's like, because it's very, being in such a big, stress, it's a stressful operation. You have to make sure that, after you successfully white hat, you are able also to get the funds safely to your multi-sig and so on. So we kept working with Panoptic, and I remember that I kept asking the team, making sure that this is we still be able to get the funds afterward and so on and so forth. But I was just spinning on this because I didn't want for us to successfully execute the white hat and then lose the funds in another way. And the Panoptic team was like super responsive. They kept testing and they were double, triple testing it and making sure everything is fine. But mostly that's how a white hat operation. It was a good example of what a white hat operation means. You go first with a target that is, of course, the greatest in value, but after you also have everything prepared to go to the next targets as well, and not spend time to building them over and over and lose time to perform on the other targets. And the Panoptic team did perfectly. You guys did perfectly. You had everything prepared. We worked together to make sure that it's prepared, and we have a plan of attack once we go live, because once you go live, everyone is gonna try to replicate. And it was a successful operation. And yeah, kudos to you guys.
And that was really helpful for us too, because yeah, like you said, the failing to add a withdraw method on the attacker contract was totally possible. Like, we were really stressed out, so it was great that Mario kept reminding us, like, make sure you have this. And when we implemented the white hat attacker contracts, we not only wrote forged tests that ensured the attacker contracts behaved as expected, but we also would execute against the local fork of mainnet or the L2s as well. And we included the withdraw step as part of those tests. So that was really helpful for someone to push us to not only test that the attack executed, but also that the funds are going to be retrievable post-attack.
Great. Yeah. I'm sure you see this all the time, Mario. So I know maybe, you're just going to say audits, maybe the bounties, but what are kind of other ways like user protocol builders can really make sure their protocols are battle tested and these kind of vulnerabilities don't show up later? Are there new things you guys are working on? I've heard of like the capture the flag contest as well that Euler has had a lot of success with, but what are more, how do we become more secure building the future in DeFi?
So yeah, it's a very good question. There is not an easy answer. We have to think about that. No matter what we do, we are against attackers who have way more time than us. So even if you plan an audit for 2 weeks, you plan a CTF for 1 month, you have bulk bounties and so on. There is still basically the bad people who are waiting in the background. They're just trying to, attack you. What you can do now to protect is there are like lots and lots of ways to try to get as safe as possible, from having your own tests, formal verification, filing, and so on, to multiple audits, to bug bounties, to doing all types of engagement where, as you said, also capture the flags. All of these strengthen basically strengthen your security posture. Then you can come up with an incident response, exactly like what you guys basically hired us for, where you act in case something happens. And that's basically the last frontier, where you're also prepared in case something bad happens, to know how to react and not screw it up. And that's basically the last frontier. All of this together, it's basically part of your security posture and should be basically implemented for any protocol out there. Unfortunately, sometimes there is a law that code has bugs, and it's impossible to predict everything, think everything from the start. We are in a rapid changing market, or new things appear. Sometimes we have to rush some of the feature hours, maybe. So for now, AI did not take our place. So we are still humans, which means that sometimes we miss stuff. The only way to get secure as possible, is to think all the time about your security and try to do everything possible to improve it at every step, not all, let's say, at the final or like at the beginning of your product. That's the only way you can stay somehow ahead of the bad guys.
Definitely. I don't think this vulnerability would have been found without these audits and these bug bounties. That way somebody would have just, withdrawn the funds, and that would have been very bad. So security is our number one priority. We're working on relaunching Panoptic now, and we're doing multiple audits and making sure that before we launch, we know everything is safe. Steve, what are our plans for V2? How are we moving forward after this, and what will be different about Panoptic now?
Yeah, we have exciting plans. So the first thing we have to do is fix this vulnerability, obviously. We have two paths we could take. One is to enforce ordered lists of your positions and then hash that ordered list. And that would mean that lying about what positions you own would require finding a collision in the KEKAC method itself. So that's kind of a gold standard, but will be really gas expensive for users. The other path is to find a different way to combine the hashes into a fingerprint that is cryptographically secure. So now that we're kind of aware of this as a class of vulnerabilities, we can do our research and maybe find something better. Add hash was mentioned in the research paper that we pointed out as one possibility. Another possibility is Facebook came out with LT hash as a different hash combination algorithm a couple of years ago. That's something we're looking at. So we're researching those two options, but we have some exciting options there. We also want to relaunch this kind of, in some ways, an opportunity, right, to make some changes that we wanted to make anyways. So we've actually accelerated a lot of our planned V2 features to instead make it into this relaunch. Some of the biggest ones include a lot more flexible position management. We heard some pretty consistent feedback from users that not being able to close positions, when someone was buying up a small portion and they were in range, was really annoying. We also think that the economics could use a change. So we're introducing an interest rate model where instead of paying instead of PLPs mainly earning from commissions from options buyers, instead they actually get a market rate for the tokens they have to lend out to those that are opening positions using their tokens. So this will make PLPing more compelling. So we're really excited about that. And then a couple other features are currently in development, and we're eager to hear from people. So if you have ideas, we'd love to know. One of the ones I'm personally most excited about is the capped premia feature that will kind of replicate the TradFi options buying experience, where maybe you're bullish on a token, you'd like to simply just put some premia down and get exposed to the upside. We're going to enable that to happen. So I'm really excited about those features. We're also introducing a number of web app improvements. So we've just engaged a friend of yours, Rosalie, Yashar, which I'm really excited about. He's going to be helping us rethink some of the user flows and the aesthetic look and feel of the app. And we're hoping that this, alongside a lot of the protocol level improvements, will really make Panoptic V2 something exciting.
Yeah, I'm definitely really excited about Panoptic V2. I'm also really happy that we were able to successfully rescue the funds, and now claims are live, so people can claim their funds back. Thank you so much for both of you. I think we're probably pretty much done unless you guys have some more closing thoughts. Mario, I'm not sure how many vulnerabilities you find a day, but I'm sure there is a lot DeFi can learn from this, and moving forward, more audits, more research. But yeah, I'm glad it went as successful as it possibly could have.
Yeah, that it's. I mean, we are a continuous fight with the bad guys, and yeah, it's a stressful. I mean, it's a stressful, basically, area we are into right now, because we are touching real money, and our field is one of very interesting and also very stressful. So we just need to stay ahead of the bad guys and keep finding all the bugs, and also responding successfully to this type of incidents, which in our case with the Panoptic team was successful one, and kudos for that. Kudos for the hard work to the team as well.
Wonderful. Thank you so much. Steve, do you have any closing thoughts or?
Yeah, I mean, Mario said it best, right? We're all on the same side here, trying to make sure that people get the trustless finance that they want without, being at risk. So we were really grateful for Mario's help, the whole Cantina team's help. They were so responsive, so thorough, and really made sure that this went well. So yeah, we're happy that it did go well, and that everyone's going to get all their funds back, and we're excited to continue collaborating with Cantina for V2 and making sure we deliver a really safe, great experience.
Awesome. Thank you so much to you guys. And yeah, I didn't see any questions from the audience, so maybe we'll get to that another time. But yeah, I hope everybody enjoys their Friday. No hacks today. Just a good, calm, happy Friday and a good weekend to everybody.
Thank you. Bye-bye.
Bye.